Hi students, now we are going to discuss criteria for optical isomerism. What is the criteria? Students, asymmetry is the criteria. Asymmetry is the criteria for optical isomerism. But majority of the students, what they thought is chiral carbon is the only criteria. No, of course, one reason is chiral carbon. And second reason is molecule, whether it has a chiral carbon or not, molecule if want to be an asymmetrical molecule. That means molecule having no plane of symmetry. Molecule having no plane of symmetry. No plane of symmetry can exhibit optical isomerism. One is chirality or optical activity will develop due to the chiral carbon, and another reason is molecule having no plane of symmetry means whether it has a chiral carbon or no chiral carbon, it has a chance to exhibit optical isomerism. First we will take the compounds having the chiral carbon. What is a chiral carbon? A carbon which is bonded to an sp3 hybridized carbon and sp3 hybridized carbon bonded to four different groups. Bonded to four different groups can be called it as chiral carbon or asymmetric carbon. Here I am taking the carbon. This carbon has one methyl group and one ethyl group. Suppose one hydrogen and one chlorine. This carbon have four different groups. That is why you can consider this as a chiral carbon. That means this carbon is asymmetrical in nature. So their configuration structures can rotate the plane polarized light in a different manner. In other words, it shows the optical isomerism. Come to the molecules having no plane of symmetry. Here, having chiral carbon, having no chiral carbon, having chiral carbon, having no chiral carbon, having no chiral carbon. Student, this is the chiral carbon. It forms an asymmetrical molecule. That's why it exhibits optical isomerism. Optical isomerism is the isomers formed due to the difference in the activity of the molecule towards plane polarized light. Okay, so chiral carbon is the criteria to exhibit optical isomerism. This is the one point. Come to the another point. Sometimes molecules having more than one chiral carbon, it may have plane of symmetry or may do not have the plane of symmetry. And sometimes they have no chiral carbon but they have the no plane of symmetry. In such a case also it exhibits the optical isomerism. I want to explain these two in detail. In the previous we are discussing about the compound having one chiral carbon, it exhibits optical isomerism undoubtedly. Now we are taken a point, molecule having chiral carbons, it may exhibit or may not exhibit. This is the molecule having no chiral carbon, but sometimes it exhibits. We are concentrating such a points. Here I am taking a molecule. Here this is the carbon having four different groups. This is the carbon having four different groups. That means two chiral carbons are there. This carbon have one COOH group, one OH group and another H and the remaining this group. This chiral carbon has H, OH, COOH and this remaining group. Student, these two chiral carbons are similar chiral carbons. Here also two similar chiral carbons are present in the same way. But the point is if you are cut in this plane, the upper part of the molecule is mirror image of the lower part. That means this molecule has a plane of symmetry, having plane of symmetry, has plane of symmetry, so it exhibits isomerism or no optical isomerism. So it does not exhibit optical isomerism, but this molecule has no plane of symmetry. This molecule has no plane of symmetry, that's why it exhibits optical isomerism. Here my important point is, these two molecules having the chiral carbons, but this is the compound having chirals and exhibit the optical isomerism, but this is having two chiral carbon atoms but not exhibit optical isomerism due to the lack of plane of symmetry. Because it has a plane of symmetry, due to the presence of plane of symmetry, it does not exhibit. Criteria for exhibition of optical activity is lack of plane of symmetry. If plane of symmetry is there, it does not exhibit. Come to here, this is the molecule having no chiral carbon. What is a chiral carbon? Carbon having 4 different groups, but this carbon has a double bond. That's why in any way this carbon has no chirality, or every carbon is non-chiral carbon, or every carbon is a symmetric carbon. But altogether, molecule itself is a chiral. Take a look. This is the carbon present on the board plane, methyl and ethyl, and this is the carbon. You assume this is the chlorine present nearer to you, and this is the hydrogen away from your eyes. You imagine this is the carbon, this is the methyl, this is the ethyl, this is the double bonded carbon, and this carbon have this is the chlorine and this is the hydrogen. Here these are present in this direction. That's why you can't cut into two equal halves. That means this molecule has no plane of symmetry. Due to the absence of plane of symmetry, even though this molecule has no chiral carbon, it exhibits optical isomerism. I am repeating. So chiral carbon is not only the criteria for the exhibition of the optical isomerism, the important criteria for the exhibition of optical isomerism, whether it has chiral carbon or no chiral carbon, lack of plane of symmetry. Molecules having no plane of symmetry has the chance to exhibit optical isomerism. This is the information. Thank you.